Hello, everybody, and thank you so much for having me today at the Australian Information Security Association webinar. And I have prepared a talk on 5G evolution, security controls, and assurance. But I will also provide you some insights into the new shift in paradigm from all things security connected using 5G to all intelligence security connected using 6G. Just a couple of words about me. I've been active in the information and communication technology field now for more than 25 years, both as an industry player as well as an academic. As an industry player, I've been contributing for more than 15 years at Nokia in various roles at the global level, as well as for Huawei Technologies for more than 10 years now. And my recent assignments have been into a role of CTO and Chief Cybersecurity Officer within the Asia Pacific region, as well as Chairman of the Infomedia Development Authority 5G Task Force in Singapore. As an academic, I am currently with the University of New South Wales and serving as adjunct professor. So my core expertise is in current and future mobile communication and information systems. I'm particularly familiar with the 4G, 5G, and now we're discussing 6G, but also I've done a lot of work on artificial intelligence, the Internet of Things, and multimedia technologies. Okay, we may start now by having a view or try to be on the same page on where 5G is. In particular, I'd like you to pay attention to the global 5G landscape. So this slide presents two important things. The first is about the assigned spectrum globally, and the spectrum allocated to or for the 5G deployment ranges from 400 megahertz up to currently 52.6 gigahertz. And in particular, the allocation has taken place on three distinct carrier frequencies. So we're talking about high band, mid band, and a low band. And as we speak, we have more than 128 operators that have received spectrum in either one of those band or a combination of those. Most of the deployment are and will be in the C band. So that means in the mid band, so frequency around 3.5 gigahertz. So 5G is already massively deployed, and here you have a view of live and planned 5G launches. As you can see on this map, Australia has already a 5G communication services available commercially. And we are having more than 110 operators that have either launched already the 5G services or planned to do so. I think more interesting on the numbers in terms of connections, so connected devices already by the end of last year. We have registered already more than 230 million connections globally. Our expectations by 2025 that we will reach out 1.8 billion connections, which is around 20% of the global adoption. Those numbers and statistics are from the GSMA and the GSA. GSMA is the largest, the most important organization of telecom service providers, and the GSA incorporates most of the vendors. So now looking into the numbers, I'd like to pay particular attention to what has happened and will happen in China, because China is definitely the largest market. As you see here, by the end of last year, we had 202 million connections out of the 234 millions globally. And by 2025, we're expecting currently 822 million connections out of the 1.8 billion. So massive investments, so the carriers are expected to invest more than 200 billion in this technology within the range of 2020 to 2025. Of course, 5G is not only happening in China, it's happening globally, and the largest penetrations, meaning 90% of the 5G mobile connection forecast globally by 2025, will be in North America, Europe, and Asia Pacific, and North America is expected to have the largest penetration of those services. Now, I'd like to present you the 5G standard roadmap. So what 2GPP has standardized, actually technically specified, and what we specify in the near future. So 5G, in its release, 2GPP release 15 was completely finalized in September 2019 in various configurations, not standalone architecture, as well as in its standalone architecture, which means completely an end-to-end system. By the end of last year, we also have the finalization of the technical specifications for the release 16. And as the first version of phase 1 of the specification targeted to enhance the mobile broadband experience, now with the release 16, we're also incorporating the ultra-reliable latest communication services. And basically, these two releases fully meet the requirements of the ITU that were set back in 2015 with the publications of the ITU vision. Beyond that, now we are working on the release 17, which of course will further enhance the EMBB RLC, but in particular, the target will be into the massive machine type of communications. And then we'll follow new use cases category, and in particular, we will start working on the 6G study items that will then be translated into 5G work items, meaning technical specifications, for them being transposed into standards, for example, in Europe by the ETSI and in Singapore by the IMDA, where I'm currently the chairman of the 5G task force, drafting those particular technical requirements for the IMDA then approval. Now, going a little bit into more details, I'd like to introduce you the in a high-level content roadmap, and I'd like to start by saying that the narrowband IoT and the LTE machine type of communications are well defined as an enhancement to the 4G technology, well specified since release 12, 13, 14, so forth, and they will continue in parallel, will be enhanced, regardless the future developments of the new radio. So let's keep that in mind. Now, focusing on the new radio, what we have that already in release 15, the system is capable of supporting spectrum from 400 megahertz up to 52.5 gigahertz. And it is a fundamental difference between the new radio and the current LTE technology that has not been designed as a wireless interface, but also an end-to-end communication technology to work on frequency, above 3 gigahertz. So it's a technology designed for the sub 3 gigahertz. Only in particular cases you may hear about that this technology has been pushed even into the C-band, but practically we need to deploy the new radio. So Release 15 has defined the baseline and the posture of the phase one of 5G. Here you have some of the fundamental characteristics. It supports and enhances the mobile broadband experience. It comes along with massive MIMO beamforming and tracking by default, which was only optional for LTE, supports dynamic spectrum sharings and network slicing end-to-end, although the specification of the RAN part of the slicing is happening now in Release 17. It provides the security baseline, and I will show you what it's all about. And then the Release 16 is, as I said, being finalized. The focus is on the industrial IoT. It supports the new radio on unlicensed spectrum, standalone, or even as an adjunct communication with to the LTE. So positioning accuracy has been enhanced to 3 meters. We also have integrated access and backhaul, and then also supports completely the new radio for vehicle to X communication, meaning vehicle to vehicle, vehicle to the roadside units, as well as vehicle to the infrastructure. And in particular, it is the technology together with the Release 17 selected to replace the GSMR. So the GSMR, as we know, will retire by 2030, and the future mobile communication, the future railway mobile communication system is about 5G Release 16 and 17. Now, looking at the Release 17, we will look into improving the wireless interface, supporting spectrum up to 71 gigahertz. The focus will be on critical IoT communications. The position will be down to 30 centimeters with a way of triangulating the signal between radiating and receiving point, and that will allow us to connect robotic platforms and teleoperate them with a large degree of reliability. And in fact, what we are discussing now is not only to connect vehicles, so cars, but also unmanned area system. Release 16 will also support non-terrestrial type of access, which means in practice satellites access, not only for backhauling. And the technology will work on GEO and LEO satellites. Here you have more details. I will come back to that later, as it is also an access technique for 6G. It will support the MBMS, so multicast broadcast services, and in particular will standardize the way the multi-access edge computing is interfacing or will interface to the user plane of the core network function. Of course, that the security from the baselines for the enhanced to cover specific use cases such as industrial IoT and the critical IoT, as I will introduce you in the next slide. So how the system will evolve in practice. This slide represents in a high level possible evolutions. So the path in reality is twofold. So we may currently most of the carriers start from the so-called option 1. We have the LTE station connected to the Volt packet core. That's our 4G system in high level. Then we think of they have actually already introduced a new radio station adjacent to the LTE base station that provides the an additional pipe of data. You see here only data coming to the mobile terminal in using a secondary direct split. So when we set up this communication, you have access directly through 5G services and through the new radio station, but also split in dual connectivity through the LTE station that will remain the anchoring point for all signaling. Then the system will evolve, and in particular, we will assist at the deployment of the 5G core network, and the new radio station will be enhanced accordingly so that we have capability of supporting terminals legacy, say, in the NSA mode, as well as terminals supporting having capability for the standalone configuration. So that's basically how the system will evolve from the non-standalone configuration down to non-standalone standalone fusion. We then we will refarm all frequency currently used for LTE and all the generation that we retire for use those spectrum only for the new radio, and therefore the ultimate goal, the system will be the option 2, so the new radio, the 5G in its standalone configuration. So that's basically where, and the path mostly adopted in the industry globally, but there are also cases like, for example, in Singapore, they are keen on launching the system in its standalone, which means practically that we will overlay the existing network with a 5G system, a fresh new system, which includes not only the access point, the access nodes, but also the 5G core and the communication continuity of the communication between these two access technology or communication technology will be through an inter-system endower. As it happened now, for example, when you move, your voice shifts from an LTE connectivity to 3G or even in some cases 2G. Yeah, 3GPP has specified a different type of architecture that is especially related to the radio access network. We are talking about RAN disaggregation, and this is achieved by splitting the system into 3 parts. We do have a physical layer that remains, let's say, close to the antennas, and then we have a distributed unit which carries, say, the fast protocol, so radio link control protocol and protocols for accessing the physical layer on a distributed unit. And then we have also the possibility of separating further the stack and centralizing the radio interface protocol that do not require, they're not so stringent in terms of latency, such as the radio source control protocol, so in the signaling plane, or the SDAP protocol on a PDCP and locate the center. So this split has several benefits. So we do have the possibility of sharing resources and control processing over large areas. So basically, typically, a CU unit may integrate around 100 plus sites. So in the case of rural areas or even, say, low traffic, low capacity configurations, configuration could provide a certain benefit, but it has also some drawbacks, because as such, it relaxes, yes, the interfaces, transmission interfaces, but on the other hand, the capacity it can handle is limited. Also, it is limited the latency, limited the latency support. So that means we have a larger delays in the communication between the mobile phones and the central unit. Therefore, for a sensitive and larger deployment scenarios where more capacity, more devices has to be connected, it is favorable to have the CU close to the distributed unit. And in practice, today we see that they are basically co-located, and that will probably remain the way the system is deployed. Okay, 2GPP also specified the way of achieving integrated access protocol. practically means that the wireless interface here used for access is also used for providing backhauling services. So we need to have in place an Arduino base station that provides an exchange service to other nodes, not as a backhaul, but using basically the same type of interfaces used here for access. Where we see the benefit of disaggregated system is through the deployment of network slices, and we see that we may consider a single physical infrastructure in this particular case by visualizing the functions. In the CU, we have the possibility of orchestrating them, positioning them, and therefore meet different type of requirements, not only in terms of speed, but I think especially in terms of latency or even capacity. So see here, by placing the CU function close to the edge, so edge means anything around the end user, in particular, we relate that to the antennas of the base station, we may reduce latency and improve also the reliability. So to provide better voice services, or we may think of critical connectivity, where requirements in terms of latency they go below 5 milliseconds. And instead, if you want to provide, say, still good communication service and the provide vendor experience, or if I think of massive shuttle connectivity, it could be beneficial, say, to relocate this particular functionality close to the regional data center so that we can achieve a massive resource sharing and controlling processes over larger areas. Okay, with the O-RAN Alliance, we have the introductions of additional interfaces, functions, and functional splits and disaggregation. And this slide, taken from this work you have here, makes a summary of the additional functionalities and interfaces specified by the O-RAN Alliance. And as you may see here, they introduce two important, in addition to adopt the same type of configuration as in 3GPP, as far as the CU and the split are concerned. They also open up the definition of standards between the distributed unit and the radio unit. But more importantly, they introduce two new important logical functions, one is non-real-time radio intelligent controller and a near real-time and the non-real-time radio intelligent controller with capabilities of providing services, improved performance, and other tasks in quasi-real time, or even take longer statistics and then think of relocating functionality or anything, perform tasks that would require a longer buffer period, longer statistics for them enforce a specific action. This comes along with expanding the threat surface and attack surface of the network, because let me see here, more interfaces will be introduced as a consequence. New risks are related to the lower layer split, as well as the disaggregation of software and hardware using the cloud, and in particular to the additional interfaces introduced between the different logical elements. Okay, now entering into the security chapter of this presentation, I would like to introduce you the most important requirements we are having from the industry. So overall, I can say that the potential threats are the same as we have been having with the 4G, but there are specific, say, requirements coming. I would like to review with you because that are strictly related to the 5G system, because of how it is used, the user scenario, and in particular the virtualization and the slicing capacity that we need to consider. So the first set of requirements is coming from the vertical sectors. They are related to the availability, and what they are demanding for is rather clear, because we are no longer thinking of now with the 5G connecting simple smartphone. So if I'm losing connectivity, it's okay. I can again reestablish the call. There's nothing of major concern, but if you consider here, for example, losing connectivity, missing out availability of the system when we are teleoperating a big object such as a car, a robotic platform, here, a truck, a excavator, I mean, the problem could be massive in terms of the impact, the harm would be very high in terms of safety, but also in terms of missing out massive productivity. So we need to have a system extremely reliable. We're thinking of about 5 9, 6 9s, and even more in terms of reliability. Other set of requirements are coming from our telecom service providers, and on this slide you have a summary of those. Here we are after integrity or confidentiality information, which is crucial when we are using the mobile edge computing platform, because what we're doing here, we're introducing a platform, a proxy, or service applications very close to the core network. So there are interfaces of services exchanged between peer entities that would require particular attention to avoid any kind of evasion or intrusions or attacks from the reciprocal organization involved into the realization of this particular solution. Slicing also comes along with some concerns. So this particular way of chaining the network functions end-to-end demands for end-to-end encryption that have to be isolated. So we need to address this problem as well. The massive connectivity is also one of the concerns that our carriers have. So we need to find a way that 5G protects to potential distributed denial of service attacks, not only say in the signaling plane, but also into the data planes. And then security management, we need to provide a way of an easy way for our network administrators or network owners so that they could achieve a way of having in place security orchestration, automation, an easy way to respond to any detected potential attack, fix up the potential vulnerability, anything that is in the system, and possibly be assisted by the artificial intelligence security capabilities. Yeah, now on ORAN, there are also other requirements coming from industry, and those requirements are in terms of integrity, confidentiality, and availability, so touching upon the all the security domains. And this slide, you have more information behind this link. Clear shows that there is a strong demand for the security assurance standards. And here you have example of potential weaknesses of the system, which may lead to threats, vulnerabilities. So you may see here the introduction of the applications at this level, new interfaces involved, algorithm, artificial intelligence algorithm coming into the picture. And then, of course, we have different type of communication channels, many layers, the trust chain that would require protection, virtualization, platform, especially when we think of addressing the life cycle management of different visual network functions and the utilization of containers, where basically we don't have the possibility of ensuring the creation of security boundaries due to the loose access to the kernel resources. And then the last set of requirements, I would say extremely important, coming now from industry again, and it is the demand to having in place a globally trusted and mutually recognized security assurance scheme now in place. We have, just to mention a few like common criteria. So all those criteria are excellent and are currently in use, largely used, especially for the IT, in the IT domain, and information security protection, excellent. We're now seeking for something strictly related to mobile communication system. And that is where the 3GPP and the GSMA are coming together into the definition and specification, the network equipment security assurance scheme that I will present later through the course of this webinar. So that is a clear requirement. We now need to have in place a scheme which is truly globally trusted and authoritative and mutually recognized for security assurance of mobile network equipment. Yeah, there was a question about the exposure to radio frequency, electromagnetic fields, RF. This is not about security, but safety. And I'd like to touch upon that issue as well, because there's been many conspiracies, and hopefully now we can put a stone on it and then really come to the conclusions that the 5G will not have a negative effects on the people's health. I made a summary now of the latest studies and in particular conclusion drawn by the European Commission, extracted by the new guidelines from the International Commission on Non-Ionizing Radiation Protections, which comes out with important conclusions and results. So, based on scientific basis, we have that there is no evidence as of today that the radiations within this range of frequencies, so the radio frequencies from 100 kilohertz up to 300 gigahertz, would have any impact on inducing or causing cancers or other type of adverse effects on humans. The only thing that was identified through this epidemiological analysis or long studies is that we do have nerve stimulations or heating, especially our skin gets warmer, and here you do have the corresponding restrictions agreed globally and now basically in place. There's no changes with respect to the past, say, experience and end levels, and the conclusion now that the 5G basically will not have a negative effect on the people's health, because practically, as you may see here, the transmission power and the power, the level of exposures in terms of watts per kilogram, so that is the SAR measure, or even electromagnetic fields are lower than what we had earlier with the previous system from 4G, 3G, 2G, and even other type of communication. Here you have example of power at the antenna feeder, and the way that the signal is radiated. As you see here, you have a beamforming technology with a very directive antennas or wave arrays to confine the transmission really from the antenna to the end user devices. So there is basically no effects on humans while you are standing under the antenna. So we may sleep well, and with that, I suggest you to look into the corresponding references and learn more about those conclusions. Now coming back to the security, we have that the 5G enhances further the 4G security posture, which was, by the way, really secure and safe as a system. As you see here, it is a summary of the basic announcements coming in the phase one of the system, so the one that has been basically already deployed massively globally. And we have that the user plane integrity is also protected at the radio interface. We have privacy preservation also supported, as the user identity is concealed, so it's hidden since the communication is established, then we have the possibility of setting policies at the flow level, granularity. Now with the 5G, we do have a unified way of authenticating the end users. This is the first time in history that with the introduction of the 5G core, we do have the same type of mechanism we show you to authenticate, authorize, and have accountability on the end-to-end communications, regardless of how you may access to the 5G services. That could be through, say, 5G to the announcement or the LTE, or using the new radio, or even using the Wi-Fi access points. We also encrypt now the communication between the visited and the public land mobile network, basically enhancing the roaming security. Now, just a couple of words about the key generation hierarchy in 5G. I've adopted and improved this slide from Rainer Sturzfold, a friend of mine from Rode Schwarz, and I recommend also to look at one of his recent talks in this matter. Really, really excellent presentation. Just quickly, basically the 5G supports two fundamental mechanisms for authenticating, authorizing, and achieving secure communication. End-to-end, those two mechanisms are listed in here, depending on the type of access you will have into these 5G services, whether this is a 3GPP authorized access, or is a known 3GPP, or the so-called untrusted type of access through Wi-Fi. It does have the mechanisms in place. Both mechanisms rely upon a shared secret, so a shared master key, which is hard-coded or based in the terminals and the SIM card, and accessible, embedded, hard-coded in a SIM card, and also available in the core network, basically in the repository function. And from this key, and then derive, following this hierarchical method, all keys across the entire system, both in the case of roaming, or even, sorry, in the case of having a communication within the home public line mobile communication system, or even in the case of roaming. So accessing your services through a serving network that will operate as an function. All authentication and the concealing of the end user identities always done by the home network. So you see here how the keys are derived, cascaded, and you may also see how the different keys are used then for integrity protection of the signaling and encryption of the signal at the wireless interface, both uplink and downlink, as well as how the key is derived for integrity protection and encryption of the user brain at different interfaces. I have also included here the functionality coming now in release 16, which is basically the AKMA, that stands for authentication and key management access for key management for applications end-to-end. So we have a way and a possibility of authenticating the applications on top of the 5G infrastructure. This is particularly important for the Internet of Things traffic across the 5G system end-to-end. So the 3GPP does also mandates the protection of the other type of interfaces, and it is here illustrated in particular how the interfaces, when they run, is disaggregated, will be protected using IPsec, or the communication towards the core network using TSL and IP security. Here you have the protocols used and the corresponding technical specification. What we are doing here, we are simply adopting security controls already efficient and effective in the internet communications for authentication, encryption of data integrity, and authorization using the open authorization, so the OAuth 2.0, and this is basically a framework that is then used in the 5G core network service-based architecture. And here you may see how the communication between the peer entities, it is authenticated, authorized, and protected, really making the 5G core network truly safe and secure. The system release 15, as I said, it constitutes the 5G security infrastructure. And yeah, it gave us the posture, so the architecture and the basic functionalities we are having already in place, as I said, already in terms of authentication, integrity, privacy, subscriber level, service-based architecture, and interworking. It also comes along with a comprehensive framework on service assurance. And this is particularly now adopted by the GSMA and NESAS, as I will present you next. And the future releases, so the one already completed, release 16, the focus is, as I said, on the industrial IoT. Therefore, they have enhanced many mechanisms from the security architecture for the convergent communication services, down the services, down security controls for services specific to vertical sectors, such as network slicing, Akama already presented, for the protection of applications end-to-end, and then security controls for vehicles to X communication. Really is, it's of course intended. Other improvement will be in the area of security assurance, which will be then further enhanced with the release 17. And release 17, as you see here, the focus will be targeting, again, on the industrial Internet of Things. I've already talked about the MAC, so MAC will be really protected end-to-end, and also we are thinking about drone safety. And then, along with that, we have announcement to say end-to-end in terms of user plane integrity protection, authentication enhancement, and ways of avoiding or identifying and protecting from faults, base station, or other part of the network. Coming to this security assurance, I'd like to mention here and capture your attention to the GSMA Network Equipment Security Assurance Scheme, the NESAS, which is now broadly adopted globally, not only, I would say, within the industry, but also government, the security agency, regulators are interested into incorporating this scheme into their way of ensuring the security assurance, which includes, of course, a certification framework. So this scheme was completely made available and approved back in 2019. We are thinking now of enhancing that. So what is it all about? It consists of two parts. And so the first part relates to auditing, and we have mechanisms to audit and therefore validate the mechanisms and how the products are produced and the whole life cycle processes related to those particular products. And this is done by independent and authoritative third-party organization. And out of it, we get an audit report. The second part concerns, it is linked using the security assurance specification coming from TGPP, relates to the equipment security. So how we test equipment, how do we prove that this particular equipment really meets all the requirements coming from 5G, and therefore supports all the necessary security controls. These processes, again, you need to have accredited laboratories, third party, and the output of this process leads to a test report that is then made available from vendor to the corresponding buyers. And here I'm particularly thinking to our operators, so the telecom service provider, but also the vertical sectors. So as we speak, the NESAS is under discussion, promoted. I'm thinking of Germany in particular, but also within the EU. So the Commission has now requested NESA to come out with a proposal of a candidate security certification scheme on 5G, and they will take into consideration, refer, and introduce the NESAS scheme into their proposal. Just quickly to give you an idea how we could achieve and enhance further, say, the security controls across the end-to-end communications and information system beyond, say, supporting what the standards prescribes to the system. And I give you just a couple of examples, 2 to 3 examples on how the system, the posture of security posture of the system could be enhanced. We can start from the 5G core. This is an example how we may achieve, say, a better way to prevent potential attacks and achieve network resilience. So the first one, it is about the introduction of hardening models so that it would prevent extensive tentative to penetrate the control plane of the core networks. This is the access and mobility functions, just to give you an example. So we have a different type of hardening models that would basically mitigate potential risks coming from the exposed surfaces. We do also have ways of introducing a hierarchical isolation gate so that we can make it extremely difficult to penetrate the kernel of the core network. And beyond that, what we introduce in practice is the diversifications of the communication chain physically, but also logically, in how we compose the end-to-end system, introducing the physical resources redundancy, as well as pools of virtual resources that could complement each other in the case one of them would not perform properly. Another important security controls are the ones targeting the separations of the user, control, and management plane. This is still important because if any of those planes, say, could be potentially compromised, we need to avoid that. We need to avoid that this particular incident would cause or harm other parts of the network. And here, the solution to that is exactly to separate the 3 planes. Physically here, you see here the implementation may come along with the different physical ports, and we then create different tunnels. So we have the possibility of protecting each single plane and isolate that in terms of encryption, in terms of authorization and authentication, the different type of communications between the peer entities, so that the 3 distinct functionality remain completely isolated and protected accordingly. Network slicing, as I mentioned at the beginning, was a major concern. Now we have really a comprehensive security controls coming in release 16. What is all about? It is the combination of the authentication and key agreement, as I've already introduced at the beginning of this presentation, with the network slice specific authentication and authorization functionalities completed in release 16. Now, taking a look at different layer, we have first, we need to protect the access to the portal, access to the network slice templates from different type of tenants, and that is for preventing unauthorized OEM access to those particular functionality. And here, what we do, we introduce anti-tampering mechanisms by adopting the public key infrastructure methodology, so which means we introduce digital signatures and X509 certificates that exactly allow us to prevent tampering type of actions. And in addition to this, we introduce rights and domain-based management mechanisms. This is done by deploying the TSL, encryption, and authorization using OAuth 2.0, so that we may prevent unauthorized access to these slices, in particular when we compose and those end-to-end networks. Then we may prevent data leakage end-to-end. So we have our slice that goes from the mobile terminal down to the edge of the network, but then the service that go through the slices end-to-end, reaching out, say, the target network. In this particular case, we are thinking of services for the smart grid. So in this case, what we do here, we introduce 5G primary authentication for establishing the end-to-end communications, I would say the bearer service, and then we reach out secondary authentications using, again, protocol adopted from the internet, the extensible authentication protocol for accessing the network to the enterprises. We then provide differentiated keys so that the encryption of each of the slices is done using a separate keys. And then we also introduce privacy protection, or we preserve privacy by ciphering the so-called network slice selection assistant information, which basically defines logically the composition of your network slice. We may then add firewalls for access control and network encryption, of course, wherever we are having access or thinking of the transport network layer outside the scope of the 3GPP. In addition to this, we may prevent resource abuse by simply introducing diversification and resource isolation. It practically means to use different type of elements and introduce redundancy, separation, and isolation between virtual machines. And even if you're using the container type of technology, it's always good to separate run them on a virtual machine so that we have a complete isolations between those communication services. Okay, then I think it's extremely important that to have in place a security operations center that would allow us a very fast detection and response and recovery from any possible and potential incident or attack that may come from the inside, say, from inside the infrastructure or from outside the infrastructure. And here, the recommendation is to have at least 3 main platforms in place and have access to interfaces, but also inside different type of network elements using security agency to observe, capture, collect the data extract logs, anything that could allow us to have transparency and understanding of what could happen and immediately detect any kind of awkward behavior or attempt to exploit any kind of potential identified vulnerability. Ideally, we should get that particular security agency from the corresponding vendor, because a native agent for sure has better access to various type of interfaces, services, and entities, or say even virtualization platform. Then use a third-party provider that would tap most probably only at the different interfaces, which, by the way, could be even encrypted. So it's very hard, say, to achieve transparency of what is ongoing into your system. Okay. On top of it, as I said, we need a security management platform that is for security management. Practically means to set the different keys, certificates, identity management, and so forth. We do need a platform for security analysis, strictly linked also to the security assurance of your system in place that allows a fast detection of any kind of signal in store, but also misbehavior into the user plane and attacks on the OEM plane as well, so that you can intervene in real time and take all the necessary measures to respond immediately to potential threats. And beyond that, we need a security control platform. The security control platform is about security policy orchestration and automatic response to potential threats identified, and for example, block any kind of attack attempts, and if it happens, quickly recover from a possible part of the system that have been harmed by potential and effective attacks. To achieve really a resilient, trustworthy, and end-to-end system, we need to have the collaboration of 5 key organizations, because usually what we tend to do is to pass all requirements and responsibility to vendors, which practically, yes, that is important, that the vendor, they come out with trustworthy product, meeting all possible security requirements. I'm thinking of the NESAS to start from, but we are also having other organizations that play an equivalent important role. So, for example, if vendors are responsible for equipment and device security, we do have operators are definitely responsible for the overall network resilience and operation security. And then we have the application providers that are basically responsible for the end-to-end security services. And beyond that, equally important is the contribution coming from the standard development organization, because they are the ones responsible for the definition of the security requirements, test cases, and security controls for the vendor or the operator implement and deploy the system. And then last but not least, I would say even the most important players are within the government organizations. So I'm thinking of the government in terms of law, regulators in terms of regulatory framework, and agency in terms of guidelines, that they really come along with the up-to-date law, regulations, and implementation, specification, and supervision, so that we have a constant and continuous exchange of information towards improving the posture of our secure system end-to-end. Now, quickly, a couple of words about the 6G and why we are thinking of already about the next generation system. And I would like to start from a vision. That's basically my vision, the vision that I formulated based on an in-depth analysis of the key trends. So below you have key trends or demands or challenges. Here you have potential solutions to the problems, and then that's the vision, basically, that all intelligence will be connected with a zero trust model through digital twinning using 5G, 6G, and the machine reasoning will meet the machine learning at the age of the network or the information and communication system. Let's try to understand why I have come out with this compelling vision that will lead them into the mission of the 6G, specifically because, as you may see on this slide, I've taken from the Italian Institute of Technology, from Roberto Cingolani and Giorgio Metta, a friend of mine, by the way, that they have demonstrated how inefficient is AI and has to be used only when it is extremely needed. And the calculations show that the cost per operation are 1,000 to 5,000 higher in machine than in humans. So coming to this configuration, that's the son of Roberto Cingolani. This is ICAB, I would say the cyber son of Giorgio Metta. What we have is the chocolate given to the son of Roberto will allow him to perform tasks for weeks, and whereas the equivalent power energy provided to the ICAB would allow him to perform only 2 hours. So that makes you think that we need to centralize the intelligence. So practically means the brain or the robotic platform needs to go at the edge. Therefore, justifies my conclusion above. Then the intelligence must also necessarily go to the edge, not only in terms of, say, energy efficiency, but also to reduce latency. I cannot go far because the speed of light has certain limitations. So 2 ways communication between these 2 points to stay below 1 millisecond would require these 2 peer entities not to go beyond 150 kilometers. So practically we need to reduce the physical distances between these 2 points. So the intelligence has to go at the edge of the system. The machine learning must meet machine reasoning because machine learning is charged as many flows and limitation biases. So we need to incorporate also reasoning systems, which practically means reasoning. The intelligence system means a new way of representing knowledge, a new way of having abilities to process this knowledge, in particular draw conclusions, take decisions. Then what we must do absolutely is to improve our efficiency and productivity and reduce the CO2 emission or greenhouse gas emissions. This is a must now, and that is only possible through this digitalization and digital platform. Therefore, I'm talking about digital twinning. And finally, basically, the new shifting paradigms is that looking into the future, we will not only connect objects, but we will connect the intelligence, anything around us. So the new shifting paradigms will be that all things will be connected through trustworthy, connected, we will shift from all things connected with the 5G to trustworthy, connected intelligence with beyond 5G and 6G technology. So the vision we are having of the 6G is represented on this slide taken from one of the recent discussion Dr. Tong had publicly. So the target with the 6G is to bridge the physical world with the cyber world. So that requires basically the introduction of new communication channels. Here you have some example of those. The system will operate millimeter wave or even terahertz, so we do have capability of sensing. Since like a radar system, now we have the possibility at that frequency really to have the neural age, so meaning the next generation of the base station having capability of a complete computer vision. So the two channels in the uplink will be sensing and learning. So it is an immense, infinite amount of information will be then incorporated into the next generation system for, as I say, representing properly this knowledge, having a new ability to process this knowledge, and in particular, having a capability of achieving important decisions, not only for improving the performance of the network, but also for performing a number of new tasks. In the downlink, since we need to bridge the cyber world to the physical world, we are thinking of virtual, especially virtual reality as a channel, but also the tactile feedback, in particular the haptic feedback, will be made available from day one, which is currently not possible with the 5G because the end-to-end latency would stay below definitely 5 milliseconds. We are even thinking below 1 millisecond. And then inferencing, the possibility of exchanging services through machine learning type of pipelines will be a part of the signaling communication system. The access to the network will be not only cellular, but the satellite system will be an integral part of the access technologies, and the low Earth orbiting satellites will be used. So there are satellites that basically run extremely fast, and the orbit basically is covered in about 1.5 hours. At the altitude from 300 to 1.5 kilometers, which practically means to achieve latency lower than 3 milliseconds, which practically entails that it is the latency is reduced even with respect to deploying fiber, considering, say, the curvature of the Earth. And we can achieve large coverage from 100 to 1,000 kilometers. Yeah, the network architecture drivers are completely different with respect to the ones we have been following or leading, say, the design of the 5G system. We are shifting from cloud-centric to artificial intelligence native. The system is gonna be as a sensor more than information-centric. We are no longer talking about security as an enhancing mechanism as we have done for the 5G compared to 4G, but we think of defense in depth strategy with the zero trust model, and then we need to be user-centric, and the end user is expected to be a prosumer, not only consuming, but also generating new services. And here I want to give you just a flavor of what it means to connect all intelligence. So this work has already started in the ITU. So you have a focus group on machine learning for future networks, which also include the 5G. Probably it's not going to be happening release 17, maybe 18, 19. So the coming releases, they have defined the concept of machine learning pipelines, different type of nodes. And here you may see how those nodes will be distributed across the whole system. So in the devices, at the edge, and in the cloud. So the whole different type of functionalities, the models, and the machine learning subset will be distributed depending on the tasks, which will be then enforced through the intent. Intent means a representation of the use cases, which subsequently would allow us to make decision upon the placement and how to chain the different type of the different kind of machine learning functions. And then we will have a management system, denoted as machine learning function orchestrator, that through measurements will optimize the deployment of the AI. Now, thinking of the security aspect, we need to definitely protect end-to-end any machine learning pipeline and exchange of services between different types of pipelines. So what we do in practice, we introduce a new layer. So we had a data plane, the control plane, the management plane, and now we are thinking of an artificial intelligence plane. There is an interesting work, before I'm concluding this webinar today, by the ABI research. You may download the white paper. I have analyzed it and then consolidated the main conclusions drawn in this work. They have a list of potential threats and novel events suspected towards 6G and possible security controls. Yeah, they're expecting high, say, they set as a high risk level to the massive machine type communications, the possibility of, say, bad guys of using quantum computers to break complex encryption algorithm. I doubt that, but anyway, that's one of the potential threats. And then we are having possible security control mechanisms. And I'd like to mention in particular the zero trust architectures and the distributed ledger technologies such as blockchain, because we must achieve a system that truly protects guarantee the integrity of the communication. At the same time, we need to have a zero trust so that we are really authenticating and authorizing any type of services or exchange information in the system. And in this work, they're also advocating for security by design. So we can do much more, I think, what we have done for the 5G. So in conclusion, I'd like to invite you to adopt and contribute to the NESAS, because this is basically a security assurance scheme which is customized, authoritative, unified, efficient, and constantly evolving. And this NESAS basically could be a part of the certification and certification processes against a predetermined set of security standards, conformance programs, and policy for security authorization in any country. Thank you so much. We will stay in touch, and I hope we can connect on LinkedIn. And here you're having a number of contributions you may use as a reference. Thank you so much, and goodbye. Yeah.